Today we'll also allow you to put questions which you might have, and you can ask Gurupreet. He'll maybe take them at the end of this talk. So this is we'll be taking questions through Slido. So you can just go to slido.com, enter the code 111, and put in any questions you might have during the talk, and maybe Gurupreet will take them at the end. So with that, all over to you, Gurupreet.
Hello everyone, hope you're having a good afternoon. I will start with my brief introduction. My name is Gurupreet and I work as an Android developer in Foodpanda Delivery Hero, and I'm based out of Singapore. So today we'll be talking about the future of Android UI with Jetpack Compose. Before we dive into the future, let's just see what are the current drawbacks we face during designing our current UI framework for Android. So the current our custom views are very hard. They have a lot of boilerplate code like custom view XML, and then you style files, and you have to create that just to create your custom button or a custom text. We have excessive inheritance going on, like checkbooks extend compile button, which extends button, which extends text view, and then we are inheriting the property which may or may not be used by the view itself. And our views are not state driven, so they have to update their state, and they do not manage their own state by themselves. And ultimately, our view classes ultimately become a God level classes when we keep adding more and more functionality and inheritance. So these are a couple of the drawbacks. Now see, what does the Jetpack Compose do? So Jetpack Compose is a modern toolkit for native UI, and simplify and accelerates the UI development. So let's just see some points about it. So it's completely unbundled from the existing UI framework. Means it does not depend on our legacy views or existing views. So it's a brand new fresh start, and it's completely have a new Kotlin compiler plugin, which helps us render the UI. And it's built in keeping in mind the material design and theming. So all the compose views we use are actually already abide by the material design and the theming rules. And it's compatible with the existing code base, so we do not have to scratch our existing app to just use Compose. It's compatible, and we can use it with the existing code as well. And it enforces us to use composition over inheritance. So instead of inheriting all the property, we try to combine multiple project views and then create a Compose view. So key things to remember about Jetpack Compose is it's declarative, it's reactive, and it's unidirectional. By declarative, I means is you describe the UI by calling a series of functions, and that transfers to the UI hierarchy. So if I say like it's a column, then a top app bar, and then item list and bottom app bar. So it described in a declarative way, and we expect the UI to look in the same way as well. Similarly, Compose is designed keeping reactive model in mind. And whenever there's an underlying state changes, so views supposed to react to that, and the Compose have kept that in mind while designing the views. And we already have started using the unidirectional data flow, where we make sure that our view models are passing state to our activity, and any action we take is passed back to the view model or the presenter. And I think the Compose double downs on that, and it makes sure that the Compose views are all built to consume the view state. So it does not care about what other data is coming from. The view only care about the consuming those state. So data always flows downwards, and the events flows up the tree, maybe to the view model or the presenter. So now we know what Compose is built as. Let's see some of the basics of the Jetpack Compose. So Compose app is completely built using composable function. It's regular Kotlin function with the composable annotation. So once we annotate any function with the composable, it renders the UI in the hierarchy. So if I call a plain function, plain text, and annotate it with the composable, so it's responsible for rendering text. And if I annotate my button with a composable, it's responsible for rendering a button. So what does the composable do actually? So it's actually does not do any annotation processing, but actually alters the function type of the function, which is very similar to what suspend do to the suspend functions. And then the Kotlin compiler is responsible for rendering the UI. The other similarity with suspend function is composable can only call other composable. Because similar to suspend, they have a calling context too, which is passed throughout the hierarchy. So only composable can call other composable. And all the practices we use with our normal functions, like breaking to small functions, combining multiple functions, returning from function, and all the Kotlin best practices, we can simply use with a composable function as well. So let's just see some of the material composable function that already is provided to us. So we have text, button, text field, and checkbox. So they all renders button, text view, and the respective element on the screen. We also have the layouts. We have a support for column, row, box. So column renders in a linear way, row in a horizontal way, and the box rendering on top of each other. We also have a support of constrained layout, as well as scrollable row and column. Similar to recycler view, Compose also used the concept of lazy loading, where it only evaluates the part of the row or column visible on the screen, and then when we call more, when we scroll, then it evaluates the other part. So we can just say lazy column or lazy row. It will re-renders the element lazily, so it does not evaluate all the elements. It can go to the infinite element, so it only renders the element that's visible on the screen. That's all we are writing to write a recycler view or a horizontal recycler view from our side. So modifier is a very important part of the composables, because like in XML file, we write the attributes. So modifiers do the same part. So modifiers is used to apply any size, spacing, background, whatever we used to do with the our attributes in XML. And they also help us to apply gesture, touch, click, and we can chain multiple modifiers to apply a multiple effects. So here you can see we have a button. If I do not apply any modifier to it, so it will render on the top left where the compose canvas actually starts. But if here I say modifier.fill max width, and then I say padding, and then I define a height, so now it renders the button like this on the screen. So modifiers is be used to design or place our views in the canvas. Similarly, we can chain multiple modifier, but you have to be careful with the chaining because the order of the chaining matters. So here, if you see, I apply a background and then I apply a padding, and vice versa. If I apply a padding and then I apply a background, so the background is only applied on the padded area. So you have to be careful, and also when setting the click listener. So if you set the click listener at the bottom, it only clicks on the padded part itself. So chaining of the modifiers matters. Icons have been made very easy in Compose. So it already provides us this Kotlin object classes like icons.outline, icons.default, which has a number of material icons available. And we can simply use calling a composable icon and pass the icon itself, and it renders on the UI. Similarly to icon, Compose have an image composable as well, which uses images or bitmap from the resource. And we already have seen the support of Coil, Glide, or Picasso, which is the popular Android third-party libraries. So you can easily call an image composable or a Coil image or a Glide image, and you just pass your data and the content scale, how you want it to scale. Here you can see the power of modifier. So I define like modifier.size and modifier.size 150 dp, and then clip to a circle shape, and you can see it easily apply those effects, and which in legacy Android was also a very hard task to do. So now we know how to create individual composable. Let's just see how we can create complex compose. So you think compose as a Legos, and when you combine those Legos to make a Lego house. So similarly, if we see here, we combine multiple composable to create a complex compose UI. So if you see here, we can see that it's image and then text and then subtitle and source laid out in a column fashion. So all we gotta say is it's a column, then we pass the image, then we pass title, subtitle, and the source. And definitely we use modifier to style them or give padding and other stuff. So now we know, let's try to create a simple app which has a grid, and then it has a nested scrolling lanes. So each lanes has a scroll to the right, and then it has a search, which also has a grid and a search bar. So let's try to use what we have learned and try to create this simple screen in Compose. So what is the starting point of Compose? You know, for starting point for our XML is set content view, which actually start inflating the XML. Similarly, we have in activity, we can just call set content, which actually starts the entry point of the Compose. So after set content, everything that's rendered is a Compose function itself. So set content is nothing but is just a extension function to the activity itself. So it's available for you to start any Compose app. So if my Compose app is just a text saying hello everyone, and then it will render hello everyone on the screen. That's our first Compose app and with the activity. So theming has been made very easy and composable. All we just gotta do is just pass the colors, typography, and we all done. It has inbuilt support for light and dark theme itself. So we just create our custom theme. If we pass the colors we want to pass, we pass our typography of the text size and shapes, and that's all. And we can start using it anywhere in our activity. So we can wrap our Compose view with my custom theme, and we'll apply the theme down the tree everywhere. And the cool part here is that this theme can be applied to the sub part of the app, and different theme can be applied to the other part of the app. So Compose make it super easy. So if you wrap only half part of the app with the theme, the other part will fall back to the default theming of the app. So theming has been one of the key part where Compose shines. So Compose actually gives us the blank canvas. As I told, if we write a button itself, it will be rendered on the top left. So what does the scaffold do? Scaffold is like a kind of ready-made composable for us, which gives us the layout, the views with the best material practices. So we know we always use this top bar, bottom bar, floating action button, and the sidebar and the snack bar. So instead of us pinpointing all our views on the canvas with the pixel perfecting it, the scaffold help us to do easily placing those at the correct placement and spacing. So we can easily pass our top bar composable to it, and we can pass bottom bar, snack bar, and floating action button, and it will renders as shown in the screen. So this process where passing the composable to the sub as a parameter is called floating. So if you are creating your custom views tomorrow, you want to create my custom button. So instead of asking user to send a resource file, you ask them to send a composable itself, so that it can be further improved or modified as the user requirement. So floating is one powerful tool that Compose provides. So now we know how to create a scaffold. So let's just see our app. So here we can see just we have a bottom bar and the body. We do not have top bar or sidebar or floating action. So we just call my app theme, we call scaffold, and we pass a bottom bar composable and the body content composable. So let's see what's the bottom navigation composable. So bottom navigation is a composable provided, which have a button navigation items, which renders an icon and a label. So icon and label is shown as below. And then it has a parameter selected, which depends on if the state is equal to home or search. Then on the click listener, it calls a lambda, which update the state to desired state. So what's this Spotify item state? Let's look into this. So it's a variable called navigation state. Then there's a remember, then mutable state. So these are all new keywords. So these are the basic core concept we're going to dive into now. So let's learn about what is this. So by default, all the composable are actually stateless. But when we use mutable state of on any values, that makes composable state aware. So if I call a count as mutable state of 0, so now this count is a state aware. So when whatever composable is consuming this count will always be state aware of changing of the count. So whenever now we click on the button, the count increments, this function will re-render itself because it's consuming that internally it's kind of observing it internally. So it will re-render itself and update the text. Similarly, if I have a isActive boolean and a checkbox, when on checkbox changed, the isActive is updated. This recall this function and then re-render the state of the isActive. And we can observe the live data and the flow as well. So it already have a support for that, and we can observe as a state. So we pass to a lazy row. It will automatically update whenever there's a change in the albums itself. This part of updating is called recomposition. So what is recomposition? So whenever the compose runs, it keeps the track of the first time it runs. It keeps the track of all the composables that's called in UI hierarchy. And now whenever there's some compose state changes, it reschedules the recomposition and goes through the hierarchy again to reflect the changes that happen because of the state. Key things to remember here is, so composable can run in parallel. So there's no way you can tell which compose is going to render first, and they can execute in any order. And composable can be called multiple times because when the state changes, this function will be recalled again and again depending on the state. So if I keep clicking on the button, this function will be called multiple times. And composable are skipped depending on the changes. So some composable will be skipped if they do not need to worry about those state changes. To do that, we can use the power of remember. So remember is kind of function memory to composable. So any value that's stored in the remember during the first composition will be returned back when the recomposition is called. So whenever, if here we can see like there's a two variable isActive and count, both are we remembering by a mutable state. And now if I keep clicking on the button, it will re-render the whole UI, but it do not care about re-rendering the checkbox because it does not care about the count itself. So that's what I mean by skipping the some composable. So it only renders the view which actually are listening to that state change. Similarly, if we have any expensive task we want to do, we always use remember so that this composable may be called for other some parts multiple times or maybe 1,000 times. We do not want to do that expensive task or initialization again. So here, if you see, I'm remembering the format currency. So this price will never change because this function just gives us a price. So whenever the count is changing on the button click, it does not recalculate the format currency, and it helps us rendering performance as well as making sure that composable is running smoothly on the screen. So now we all know these three key concepts. So let's just see what does the bottom navigation is doing. So both the bottom navigation and the body of the scaffold is consuming this Spotify nav type state. So what does it do is when bottom navigation is clicked, let's just say I click on search, it updates this state to the search. And then both the Spotify navigation and the body will be re-rendering itself because they both are consuming to the state, and it will make the search active. And let's just see what does the body do. So body is actually similar to compose. It reads the state and just check if it's a state to home, search, and library. It renders the screen it needs. So remember, the compose itself provides us a layout to render. We can use fragments, we can use navigation component, or we can use our own custom navigation depending on how we want to create our stacks. So it gives us a flexibility of creating a different type of nav graph or structure we want to structure our app. So now we can see like whenever the nav states change, so home screen will be selected. So what is in our home screen? So home screen, now we know the bottom navigation and home selected. So home screen just consists of the one top text, and then it has a grid, and then it has a lanes. So let's just see. Now we already know we will use a column to lay out this text, and we call it a home grid and then home lanes. So what does the grid do? Grid is very similar, a simple compose function that call a vertical grid, and you just take the 6 element and you render the home grid item. So home grid item is nothing but just a card with a row with the image and text in a row manner. Similarly, let's just see the lanes. So lanes is actually have a title each lane, and then it has a scrollable row. So we go for each lanes and we just say we render a title and then we render a lane. So lane is just a scrollable row. So we can just say it is observing a state, and we can just say lazy row for, and it will renders the those items. So what does the Spotify lane item is? As we already know, it's simply a image and a text in a column manner. So what we gotta do is just say column, and then we pass the image and we pass the text. So now we move back to the search screen. So search here you see also is a grid. So it's going to be very similar. So top search section, and then we say search grid. And the search grid we just call vertical grid before each album we are observing. So here it's the search grid item. There's a lot of interesting thing happening. So here you see the search grid item. We are applying the gradient by just power of modifier. We just say horizontal gradient and we provide the gradient. And here in the image, you can see we define the size, we align it to bottom, and we just use the draw layer to redraw this state to 45 degree. And then that's all we need to do to modify the state of this. And now we see the gradient here is happening is it's taking the dominant color from the album, and then it's drawing the gradient on the screen. So let's just see, we are getting this get dominant color gradient, which is a very intensive function. It's going through the pixel of the image and get the dominant color, most repeated color. So we want to make sure we do not call this function again and again, because this search grid composable can be called 1,000 times. So we make sure we use to remember here, and then we pass the album ID. So when this album ID is composable is called again and again, it will just use that as a key map here and just get the already calculated dominant color, and it will just assign that color. So the remember actually gives us a powerful tool which we have to use with the responsibility to make sure that we use the rendering, we improve our rendering performance instead of doing very expensive tasks on the composable itself. So now let's recap what we have made in this couple of lines of code. So we just said we have a home with a grid, title, and the lanes. In the grid, we just call vertical grid for 6 items. And for the lanes, we just say it's each lane with the title and the row items in a scrollable manner. Similarly, for the search screen, it's a vertical grid, and vertical grid just goes through all the albums and lists the albums. And now looking at the animations, so Compose I actually made animation super easy. We just call the animation property like size, color, position, and it just animate for us. We do not need to worry about anything. So here, if you see, I have a pizza image, and then I just say if pizza selected 250 dp, if not selected the 100 dp, and same opposite condition for this. So if you wrap this with the animate, it handles for us. That easy it is. But this is a single slot animation, means it's either true or false animations. We can have a multi-state animation also. So here, if you are on multicolor animation, so we define a transition definition which have all the state like animation state to start, mid, end, and we just pass the animation we want to do on this color. And simply when we have we define the animation saying like transition animation, we pass the definition, we pass the initial state and then final state. And we can use this color anywhere and it will assign the animation to that. You can have an infinite repeating animation as well, or one shot animation. So multi-state animation gives room for so many different state animation which we can use while sliding, while interacting with the view. And I think it's gonna be very awesome to use. So Compose actually is made keeping testing in the mind. So even though it's a very new framework, but they have laid out the core of the testing itself. So Compose uses semantics to give meaning to composable. So when we render the Compose tree itself, then it renders a semantic tree itself, which knows kind of how the views are laid out. So semantic is its way to give reference to the view, because Compose views does not have any find view by ID or anything. So we use this to give them a reference. And then it used test tag also, which is similar semantic, provide us a kind of way to refer to those views, because when the composable tree renders, then it creates a semantic tree itself, which will keep track of all the trees and provide us the information how we can use that to test. And once you define that, you can just create your compose test rule, which is on your activity, and then you just simply call set the content, whatever you want to part of the app you want to test on, you just set content that app, and then you can just say on node with the tags, on node with the tag, or node with the text, and then you can simply use this as a displayed or perform click actions. So Compose actually does not depend on the Espresso or any third-party tools. It already have laid out all the basic interaction and the features itself. So it provides us a hierarchical matcher, which is used to find all the hierarchy in the compose tree. Do you want to go up, you want to go down, you want to check the siblings, you want to check the ancestor, you want to check the parent. So all is provided already, and you have already laid out all the basic actions we have, like perform click, perform gesture, swipe right, swipe left. So all this is already provided without worrying about any third party support. Now let's just see, we have this view, how we're gonna test it. So first we give our bottom navigation, we give it a test tag of bottom navigation bar. And then in our compose test rule, we just say on node with this tag, just check children and assert that they are equal to 3, and assert all have a click action. That simple. So we can just simply use this tag to refer to any views we want to test. And similarly, now if we want to test that if the bottom navigation has a home entry, so we just say on a node with the bottom bar in children's, you just filter the one that has text to it, and then we check assert exists. So this all are independent compose testing tools. It does not depend on Espresso or anything. And now if you want to test if the siblings are not selected, just the home screen is selecting. So we just say on node with the text home, so assert it has a click action. So we say assert it's selected, but on the siblings, now it's using the matcher hierarchy to check all the siblings, and then assert that all of them are not selected. So Compose actually have laid out all the basic of the testing, and I think it's gonna make not just the making UI very fun, but the testing as well. So now the main question is how you migrate your app to Compose. So Compose actually gives us the backward compatibility. So you can migrate small part, you can migrate a fragment or an activity depending on your use case. So you can use a Compose view in your view hierarchy, like in your constraint layout, in your linear layout, you can use a Compose view easily. So if you do not have to create a new activity itself. Also, you can use Compose fragment by fragment. You just create a fragment with the Compose, and you use that in, new fragment with the Compose, and you use that along with your other fragments. Or you just can create a new Compose activity, which would not have any XML dependency. It will start as we saw earlier, that a Compose tree with the set content method. So let's just see if you want to use the Compose view in your existing fragment or activity. So what you can do is in your layout, wherever you have, you just can call a Compose view. And now you get the reference to this view by find view by ID, or you're using binding or other stuff. And then you just call a set content method, which we earlier call on activity. You just call this method, and then you are back to Compose world. So it's very easy to add Compose to your existing activities and the views itself. Similarly, if you want to use, you have a Compose activity already, but you want to use your existing views that are already in your design system, or something you have already custom views, you do not want to write them in Compose. So you just can use this Android view block, which actually helps us to create those view. You create those view like Android text view, and then you just pass in this view block, and now it will be available for use in Compose. So this Android view composable help us to use existing or our custom or legacy views in the Compose itself. Now, whenever there's a, let's make it a state aware as well. So whenever there's a state change, so this lambda will be called again and again, especially those big views like add view or the map view, which are very huge code base, may not transfer very fast to the compose itself. So you can always use the mix and match of those existing views. Like here, I'm using the add view, and I apply the smart banner, and I apply the unit ID, and then I apply the load request, and see how these views are always wrapped in a remember, because this composable may be called again and again whenever the something changes, some state changes. So we do not want to do this expensive part of creating the views again. So we use the power of remember to create once, and then we wrap it in a Android view to use it as a compose function itself. So compose makes it super easy to use existing views in a compose, or having a whole compose view used in existing apps. Let's just see what's the Kotlin tool for the compose. So Kotlin actually provides special items that make it very easy to write a good compose code. So here you can see we see some of the Kotlin's feature that really enhance the compose code. So default arguments, we always use it. So here you can see the text actually have all the default arguments like the color, font size, letter spacing, overflow, and all the other stuff. But we do not need to use that because they're already defined to a base material theming and material styles. So only if you want to change that, you use that. So by the power of using the default arguments, we can simply write text, compose text, instead of writing all this again and again. So that enhances the readability as well as the number of lines for compose code. Similarly, we have high order function, trailing lambdas, that's used everywhere in the compose. So here, if you see the card itself, so card has a default value, but then it has a content, which is a composable function passed, and it's on the last parameter. So we can easily refer to as a lambda function like this, which makes it more readable instead of we passing the content in a function itself. Similarly, the column also uses the content at the last parameter, so and pass the composable, and which helps us write column in this fashion. So if you're creating your custom view as well, so make sure you take use of this high order function and trailing lambdas to pass your content you want to consume to at the bottom of the screen, so it can be further used as a lambda expression. Similarly, here you see for column, there's a column scope is passed as a receiver. So what does it do? It uses the property of the Kotlin receivers, which make sure that this lambda is called in the context of this scope. So when the column scope is present here, so it makes sure this view only use the property that's provided for the column scope itself. Similarly, when you use row, the row scope is passed to the lambda. Also, the other features of the Kotlin, like delegated property, destruction classing, and other programming features are used in Compose everywhere. Here you can see we were reading the mutable state. So we can just use delegated property by using the keyword by. And similarly, here you see it's just a Kotlin code with the when conditions and a range. And it simply is rendering a column fashion, all the text view. Telling it the size of the teachers is 0 to 5, it's small, 6 to 10, it's medium. So how this works so cool with the Kotlin code itself, and it doesn't even feel like it's writing a UI code. So definitely, I think Kotlin plays a very important role, how it has shaped up the Compose itself, and looking forward for more Kotlin features and more Kotlin properties used in Compose everywhere. So Compose is already have a support for desktop. Here, as you can see, we are using the exactly UI we created, and you just copy paste in the desktop app and it will be available. And the theming you can see also is very simple. You can use it in mobile app as well, because the theming is, it automatically supports the material theming. So it has both the night and the light mode. So Compose for desktop is also underway. Hopefully it will be available very soon. So final thoughts on this are the Compose is still in alpha, but the community has already doing great work, and there's apps like Flappy Bird and other stuff already available, and there are so many demo apps available. And for it being in alpha, it still is very mature and has testing available, and it makes sure that it's definitely laid out very good base for the future framework. So as an Android developer, as you have seen, I definitely feel it accelerates the Android development. We are writing the straight Kotlin code straight in Kotlin files instead of defining in the XML and importing again. And fits perfectly with our current architecture, whether it's MVVM, MVI, MVRX, because the composable itself are made to just consume view. It does not worry how you are observing those view, how you are providing those view states. So it just renders those view state provided to it. So before that, you can use view model presenter to provide state. It depends on you. And especially the Google is always enforces on interoperability and the backward compatibility. So which will help us use Compose screen by screen or fragment by fragment slowly. We do, as we saw, like we can just start using Compose. You can replace your existing recycler view with the Compose view and then write a lazy row or lazy column in it, and you will all good to set using Compose in your existing view. Stable release is expected somewhere around next year, so hopefully maybe next I/O or somewhere we'll have a stable release, but the beta should be sooner than that. And I think we use a lot of Google libraries already in beta. And JetBrains is bringing support for the desktop as well, which will not just help us to port our application to desktop, Mac, or other Linux and other stuff, but it also is bringing support. There's a kind of hackathon going in the JetBrains itself that they tried out the web support as well. So looking forward to having a single code base for UI and providing it to the multiple states as well. So I have this Compose cookbook, which I made to just see the potential of the Compose. And as you can see, this all are completely Compose UIs. And here you can see the Spotify UI as well. And please check it out if you are interested in Compose. I think this is this definitely shows that how capable Compose is, and also have the testing shown for the bottom navigation and other stuff as well, and more stuff coming soon and soon. So there are a couple of resources you want to use to get started. So you definitely go through the official Compose samples, and you can check out my Compose cookbook. It has all the basic animations and basic widgets info. And you can use the Compose Academy by Joe Perch, which is tells all the basic individual building block of the Compose. And then there's a website by Jetpack Compose by Vinay Gaba, which actually is a curated list of all the community samples and the work done on Compose, which is a great help. And since the Compose actually renders all the UI on the canvas, so we're gonna definitely see so much canvas stuff coming from web to mobile. And there's already so many canvas animation by Alex Lockwood. Please try it out. And then there's the Dino Chrome game, and there's a Flappy Bird game as well available. So these are a couple of resources if you want to get started with the Compose. Thank you very much. If you have any queries or anything, you just reach out to me on Twitter _Gurupreet. And I hope you really like Compose, and looking forward to all of you to give it a try. Thank you.
Hi, Gurupreet. That was pretty interesting. Compose seems pretty interesting, and I personally learned a lot from your talk too. So with that, we'll go on to questions. So we can answer some of the questions that you have asked. I'll quickly present my screen and put the questions forward to you. Before you start on with the questions, if you still have any question, go on to slider.com, enter the code 111 and enter your question right over there. Or you can also scan the QR code right over here. We have tried to remove out or filter out some of the questions which Gurupreet has already answered in his talk. So, yeah, Gurupreet, here are the questions.
Okay, I'll start from the start. So can we bind a Compose view to an activity after on code? So we can, so as I told, like if you can use the Compose app when manipulating the XML as well. So you just provide your compose function, a compose view in the XML, and you can later use that view to render. But yeah, so the set content, if it's called, and we cannot call the set content view with the XML itself because which will void the meaning of the set content. So it will render the compose UI instead of inflating the XML. Current view system offer UI debugging tool like showing error bounds on device inspector IDV. So one thing I didn't add it. So actually, the compose any composable function, if you annotate it with the @preview, it actually shows you the preview in the side of the Android Studio, and it's actually very powerful. It's not just a preview; you can actually interact with the preview, and you can see how it's rendering. And I think a lot of tool will be soon available in Android Studio to do the UI debugging and especially check the hierarchy and how you're doing the rendering. I think those are the couple of tools I'm still looking forward to. But just to preview UI, I think if you just annotate any composable with the preview, it will render the UI. Is there similar tooling for Compose, or you really want the similar tooling for Compose? You need those. So I didn't get this question, but yeah, the Compose is very similar in a reactive manner, and there are other tools as well, but the Compose as a native itself to Android, and definitely hopefully coming to support to the web itself. But yeah, so it's different from a React or Flutter in the sense that they are as external framework, but it's a Compose is actually a part of Android UI system itself. How to share data from one component or child. So as I said, like the sharing data in Compose works in the sense like it always data flows from the top to the bottom of the hierarchy. So you want to share pass data from one component to another component. You make sure that they have a common state as a parent. So when the parent have a common state, so if you see like the body content here, we had in Spotify, we had home content, we have search. So they all have a parent nav state which they listen to, and each of the content renders depending on the body renders depending on the nav state. So if you have multiple component laid out on the screen, so you make sure their parent they have a common state they listen to. What about adding custom animation interpreter to animate? Yeah, so actually where I call the animate function or any transition animation, it takes a parameter as an animation where you can pass the tween animation, you can pass the spring animation and all the easing curves as well. So it's already inbuilt and you can depend, but yeah, it uses the default value from scratch. But yeah, if you want to override that, you definitely pass your own animation and own tween timing and other stuff. Current view system API decompile easily and get. Okay, I haven't tried this to getting the UI file from the Compose, but it's definitely going to be different as compared to the current view system, because current view system we already point it via the IDs. So Compose does not have a concept of the IDs in the view. So it's definitely, I haven't tried it, but yeah, I'm going to check it out. How multiple edit text on recycler view in current view system, there is many issue. So yeah, so the way Compose view works is why they are stateful is because they render they manage their internal state. While in the legacy system, we tell which edit text to be on focus, we tell which edit text to be on active, and here we have those text view. They will depend on the state, and depending on the state, they will renders if which one is listening to the state changes. Compile time safety to compose a view and yeah, so compile time safety is a very interesting topic because it's rendering most of the view after the in a runtime. So actually, the Kotlin compiler actually tells you a lot of stuff and warning and the error if you have in any of your compose functions. But I can definitely say it's gonna be very there's gonna be definitely less crashes as we see while inflating from XML, because then it's always finding for the IDs and looking for the mapping, which the compose does not need to worry about. But yeah, but yeah, it's again rendering those states in a runtime. So yeah, that's also may cause some problem, but we can always use the best practices to make sure we do not do any of the stuff. So far, even though my Compose cookbook, if you see, almost have 40,000 lines of code reached now, I don't see it. The build is still very fast, and I'm using a lot of like external libraries as well. So I don't see any build time while using the Jetpack Compose. And I feel it should be faster because there's not a lot of inflation happening, a lot of views are not being inflated. So runtime is already very fast. So build time, I'm not sure if it should impact other than just the Kotlin compiler and compiling the compose to the UI hierarchy. Those are very focused on function, not on classes. Is there a specific reason for it? So yeah, so actually, if you guys notice that all compose functions actually does not start like with the lowercase like the other Kotlin function does. That's the reason, because they want them to each act as a class itself, as an object itself. So itself represent an object. So they're not just a function, but a kind of object that will render the UI itself. So it's depend on the class. You can create a like if you see the colors the compose provides, the icons it provides, they are all Kotlin singleton classes. But the compose itself is a building block, works as a function to provide us the functionality. The classes you can use to import multiple compose, but yeah, it does not depend on a class definition also.
So with that, I guess you are at the end of the questions, and uh, we'll also be publishing this recording live on YouTube. So if you want to catch up on something, or if you couldn't attend the whole of it, you can most certainly take a look at the recording. We'll also make a tweet about it, or tweet with the recording link. So keep a watch out for that. And thank you all for uh, thank you all for attending this meetup. I hope you all learned a lot from it. And this is our last meetup for 2020. So I hope you all enjoyed. Merry Christmas to all.
Thank you. Bye-bye.
Yeah. Thanks, everyone. Thanks, Gurupreet.
Thank you. Nice meeting you guys.
Yeah. Thanks, everyone. Thanks for
Thank you.
joining.